So, um, this is homework 7. YouTube. I'm gonna record my uh, my response, my answer for this, my code. Okay. So the requires write a function that's params le 1000. So that return a list of all the primes that's smaller than 1000 with a digit sum of 10. Use the following helper. Actually, that you will use the two other function to help it. One is digits is prime and one is digit sum of n. And okay, to write the function that return all the numbers which are primes number and had the sum of all of its digits equal to 10, we write the separately functions. First is the is primes to define if the given number is prime or not. If it is a prime number, we continue to sum all the digits by function digits sum of n. Then use conditional code to decide whether this prime number has digit sum up equal to 10 or not. Then put it down. First is prime functions. So I write the conditional function to if n number 1 and 2 are the natural primes number. So first I will use the conditional if the number is 1 or 2 is returned true, and if it's not 1 or 2, so I start the range from 2 to the integer of the number n, half of number n plus 1. So half of number n is the largest, n can be divided, and when we take integer of a number that's not divided by 2, the decimal part is always removed, and this gonna be like, for example, 3 divided by 2, so it's gonna be 1 instead of 1.5 or instead of 2, so we plus 1 more. If and then so for I range to integer of and half of n plus 1. If n divide I equal to 0, so it mean there's another primes that there's another factors that n can divide by, so we return false, and if not we return true. So return true to use this function later. And the second function, helper function, we use a digit sum of n. This function we write the function is to sum the digits of all the digits of the numbers, like number 10 has 1 and 0, so we sum up this is equal to 10, to 1. So first we sum accumulated, sum accum equal to 0 for I in string of n, the string of the number. Sum accum is gonna be first is with n is equal to it to sum accum plus with the integer of I. So it's kind of easy. We did it hundreds of times, and then return sum accum. We return to recall this function later, helper function. And that's the third one. The third function is the final one, the main function. So prime le. I still have no idea why you say you name it le. What does this mean? But okay, so whatever. For I in range from 1 to 1001. So the reason why I choose 1001 is because the requirement is the primes like smaller or equal to 1000, so I choose 1001. And if it is prime, it means if this function is true, it means if the number n is the prime number and the digit sum of that number equal to 10. So we're gonna print out I mean that number. Then okay, we call it. So when I run it, it's gonna be like this. There. Oh shit, forget. Sorry. So this is. I have to um, command it. Alright, command this for. So run again. There we go. So we have 1, 2, 3, whatever, how many, more than 10 number, 10 primes number in from, I mean, smaller than 1000. So here, a plus 1 is equal to 10, right? So to generalize the function, I put is the generalize. We have a lower, upper, and ds is the sum up. This is sum up. So for I in range from lower to upper plus 1, like from 0 to 1001 here. So and where here. So for I in range lower to upper, if it is primes and this is sum up I, it is prime is mean if it is the primes number and this is sum up and that number is equal to the certain number, so we return it is number. So now I be commanded for, and then we run actually a string. This one. Okay, there we go. So I have I give this function run from 50 to 2000, and the sum up is equal to 20. And now there we go from 50 to 2000. We have 3, 8, 9 equal 20, 4, 7, 9 equal 20, 1, 9, 7, 3 equal 20, and all those numbers are prime number. Okay, so now the third one. Third one is just most harder one. I commanded. So the question 3, let's see. So print out the nicely format table. Okay, table. You might use dictionary. Okay, now I use a dictionary. So after your dictionary, I'm gonna answer those questions. So I place a dictionary L for in range from 1 to 1001. If it's prime, digit sum of is equal to digit sum of I. If digit sum in L, so at first in the dictionary we have nothing. So first if digit sum in L, we plus 1. If not, is equal 1. We can change and then print out this is the format. So the first item is center 15 long, this long length, and the second item this is 15 length, and format this is sum and primes, number of primes, number of primes. And for K in L prints um, the same format, and the first item is K, the second item is KLK. So um, when I print, I mean, then another list is M, and actually we already have a dictionary. And now the first question: is there a most common digit sum for primes smaller than 1,000? To know this, um, to find the to find how if it's a most we already have a dictionary, so the digit sum up is gonna be put in the dictionary, and uh, the dictionary gonna count how many times it appear. I mean, yeah, how many times it appear. So and then we use max function to find the values that the biggest in the, so that value is gonna be in LK, so we find max of LK. So M is the list of the L the second item of L, I mean of the dictionary. So for I in L, L is the dictionary, M append Li. So the max values is equal to max of the function. It's a function max of M. So in the list, it's gonna choose one values that is max. And for I in L, if Li is called, actually, sorry. Alright, so and then for I in L, so in the dictionary, if Li equal to max value, so print out the item and its definition. I mean, is second. How to say? I forget, but it dictionary. Okay. So now I comment this, and it's red. Uh, this is long. Alright, so now we have a, this is sum of one. We have one primes, and there are three primes have this is sum of two. Uh, and of three we have one. Of four we have so. And in 10 we have 15, 11 we have 6. Alright, so 25 we have a 1. So what is the most common digit sum up? So when we find the in the Li, we find that 19 is the max number. So to match with I19 is item number is gonna be 17. So 17 is the most common digit sum, and is every digit sum of the minimum or to the maximum digit sum possible, or are there gaps, and if so, where are the gaps in the system? So of course it does have gap. Here's for example from 1, 2, 3, 4, 5, and the gap is 6 here, so the gap is 2, and so we don't have 9 here, so the gap is 2 too, from 8 to 10 is 2, so 10, 11, 12, we don't have 12, so the gap is 2, so the gap is mostly 2, and here and so 20, we missed 20, 21, we mixed 24, so the gap is 2, and what else? Yeah. So if there are gaps in the digit sum, what is the largest gap? Okay, that's just 2. This is my math. Come on. Alright, I answer almost the question. So let's see. Nothing else. Okay, I'm gonna close it and up it to YouTube. Thank you for listening to. Bye.